Okay, I'm going to do two short-ish examples on constant acceleration questions with two-dimensional vectors. They're really no harder than the one-dimensional ones. You're just working with vectors instead. So I'll show you what I mean. So we have a particle P is moving with constant velocity for this one. And we're going to have that as being minus I plus 5j meters per second. And initially, P is at the point 2 minus 3. So at the beginning of its motion, P is at the point 2 minus 3. And we want to find the position of P when t equals 4. So constant velocity means that the acceleration is equal to 0. Dealing with vectors, acceleration is a vector, so just underline it. 2 is equal to 4, which is a scalar quantity, so don't need to underline that one. And the velocity is equal to minus I plus 5j, which I'm going to write as a column vector. So we want to find the position of P when t is 4. So we're looking to work with the displacement. So the displacement is equal to ut plus a half a t squared. So exactly the same formula for Suvat. It's just there's some vectors in there as well. So displacement is equal to the velocity times time. So 4 lots of minus 1, 5, which is equal to minus 4, 20. The only thing to be careful with this question is that initially P is at the point 2 minus 3. So to find the position vector of P when t equals 4, you need to add on that initial displacement. So really exactly the same as you would with a one-dimensional question. So it's going to be at 2 minus 3 plus minus 420, which is equal to minus 217. So P is at minus 217 as coordinates. So that's the first one. Second one, we're just going to do a little bit of F equals ma. Let's check my board's lined up. So we're going to have a force of minus 6 plus 2j newtons, minus 6I. Acting on a particle of mass 2 kilograms. If the initial velocity is I minus j, find its velocity after 5 seconds. Sorry about the smudging. Okay, so we can use F equals ma. Remember, F is a resultant force. There's only one force acting here, so we don't have to worry too much about finding a resultant, but you just add your forces together to get a resultant force. It will be a vector, so the resultant force of minus 6,2 is equal to the mass times the acceleration. That gives us that the acceleration is equal to minus 3, 1 when you divide by 2. So constant acceleration, so we can use Suvat. Initial velocity is equal to 1 minus 1, and t is equal to 5. So to find velocity after 5 seconds, v is equal to u plus a t. And so v is equal to my initial velocity, which is 1 minus 1, plus 5 lots of the acceleration. So we get 1 minus 15, which is minus 14, and minus 1 plus 5, which is equal to 4. Just as a quick reminder, if you want to go from velocity to speed, you would then find the magnitude of the velocity using Pythagoras. Hopefully you can still see this, but it's just the square root of minus 14 squared plus 4 squared, and I don't have a calculator on me, so I'll leave you to work that out. I hope that's clear. So if you go on from there to doing the exercise that I've put on OneDrive.